Good evening, everyone. This is one more session with respect to Linux system programming. Before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect, what is the discussion happened in the last lecture? In the last lecture, we are trying to we discussed about introduction to operating system. We are trying to understand what is an OS. We are trying to understand few things is there. We are trying to understand what is an OS. Second thing, we are trying to understand why operating system in embedded systems. Third thing, we are trying to understand why Linux operating system. Fourth point, we are trying to understand what are the components of an operating system. Will you agree? There are two components of an operating system. There are two components of an operating system. One is applications and another one is services. Again, there are two components of an operating system. One is applications and another one is a services. Now tell me, is it applications are mandatory or services are mandatory? Tell me, is it applications are mandatory or services are mandatory? Will you agree? Services are mandatory. Applications are optional. If one application is not there, I can use another application. If there is no service, there is no use of an application. So these are the things in the last lecture we are trying to understand. Today we need to continue with that. So before the today's continuation, we need to discuss today. That's what in the last lecture we didn't discuss. What are the concepts we are going to discuss in this module? Again, in this module, what are the main topics we are going to discuss? Just the list I mentioned here. One is we need to discuss about the process and process management. We need to discuss about signal handling. We need to discuss about file and file management. We need to discuss about in between file and file management, in between process synchronization. One more important concept we need to discuss, that is IPC, inter-process communication, that we need to discuss. After IPCs, process synchronization using the semaphores. After that, we need to talk about threads and multi-threading. After that, we need to talk about memory management. These are the concepts. How many topics are there? 1, 2, 3, 4, 5, 6, 7. 7 is IPC mechanism, right? So these are the 7 concepts, main headings, we can say, major topic names, titles. These are the 7 things. So first is a process and process management. Like in a C language, I don't know, you able to recollect it or not. First we discussed about the data types. Next we discussed about an operators. Next we discussed about a control statement. Like this, the main topic names. Here also the main topic names. All of you are getting this point, type 7 in the chat box. If all of you are getting this point, type 7 in the chat box. These are the topic names, title names. These are the main topics names. These are the main title names we are going to discuss in this module. In this process and process management, we are going to discuss what is a process. We are going to discuss what is a multiprocessing, what is a hardware multiprocessing, what is a software multiprocessing, and a few commands we need to discuss. Few system calls we need to discuss, how to create a process, orphan process, zombie process, daemon process, and few definitions we need to discuss: wait time, turnaround time. Now, what you call some of the definitions: turnaround time, wait time, delayed time, suspend. There are so many things, there are so many definitions we need to discuss. After that, we need to start writing the programs. Fork system call, system function. There are so many things we need to discuss. EXEC family of functions. And we need to talk about scheduling policies, round robin scheduling policy, first in, first out scheduling policy, SJF scheduling policy, shortest job first scheduling policy, priority based scheduling policies. All these things we need to discuss in the process and process management. One thing I need to tell you, to understand remaining concepts in the operating system, very important concept is process and process management. If you able to understand this process and process management, remaining things you can easily understand it. Again, if you able to understand this process and process management, remaining things you can easily understand it. So for remaining understanding, this is very important. So we need to give a little bit more time to understand this process and process management. After that, we need to talk about a signal handling. In a microcontroller, there is a concept called interrupts. In operating system, there is a concept called signal handling. What is a signal? How many types of signals are there? What happens when the signal is generated? And how to handle it? How to write our own ISR function? How to change the action of the signal? All those things we need to discuss in the signal handling. Next, we need to talk about file and file management. All of you able to recollect, in a C module, we discussed about file handling using the C language. In a C module, we discussed about file handling using the C language. That concept and this concept is a little bit different. Now here we are trying to talk about file management. How many types of files our Linux supports? Regular file, directory file, link file, sockets file, pipe file, like this different types of files are there. So in this, we need to talk about soft link file, hard link file, and all other issues. We need to talk about one function called stat system, called the information about the file. We need to talk about, in this we are going to discuss about how to open a directory, open dir, read dir, like this. In this we are going to talk about ls command implementation. In this we are going to talk about search command implementation. So many things we are going to discuss. Open system call, create system call, read, write system calls we are going to talk in this. And here we are going to talk about redirection also. I hope on that day you might have observed executable file name, command name, greater than symbol. I mentioned one file name so that the output of this is went to this file. All of you are observing this point. Output of this will go to this file. That is called as a redirection. Yes, nm command or something. So how to output redirection, input redirection concepts we are going to discuss. After this, the topic title is not mentioned here, but very important title, that is IPC, inter-process communication. We are going to talk about a pipe, we are going to talk about a named pipe, we are going to talk about a message queue, we are going to talk about a shared memory. Some of you might have not heard about these things. How processes can communicate between each other, inter-process communication. So very important interview point of view, very important in a company point of view, IPC mechanisms, we are going to discuss it. After that, very important topic, that is semaphores, we are going to discuss. Binary semaphore, counting semaphore, how to synchronize using the semaphores. So deadlock situation, how to avoid, what is a deadlock situation, all those things we are going to discuss in the process synchronization using the semaphore. After that, thread concepts we are going to discuss. Threading and multi-threading concept we are going to discuss. What is a thread, how to create a multi-threading, how to synchronize the threads using the what you call mutex, what is a mutex, and all these things. All these are theory plus programs. N7, in every topic program involvement will be there. Don't worry about it. Every topic, semaphore also with program we are going to discuss. IPCs, every topic program will be there. In this, I hope you might have remembered. We are going to learn the system programming using C language. I hope you might have remembered. We are going to write a system programming using the C language. Means all the C concepts involvement will be there. All the C concept involvement will be there here. So don't worry about what is a deadlock. S2. Don't worry about the deadlock. If I tell you also, it is very difficult to understand that. Deadlock is one strange situation. Deadlock is one strange situation, rarely happens. Like traffic jam. Like a traffic jam. So nobody is moving. So nobody can move also. So that type of situations, how to handle that type of situations in the operating system concept. All those things we are going to discuss. All those things I'm going to discuss. After that, memory management. Here we are going to talk about virtual memory. We are going to talk about MMU, physical address, logical address, virtual memory concept, paging, segments, demand page. There are so many things are there. We are going to discuss in the memory management. In this entire things, this is only the theory concept. Remaining modules, remaining topics are the programming involvement will be there. BE8 M2 is asking. BE8 M2 is asking about kernel. Kernel, this what? We are going to communicate with the kernel only. Kernel is nothing but what? BE8 M2. Kernel is nothing but core of an operating system. What is a core of an operating system? Can I say in an operating system, main part is what you call process manager, file manager, signal manager, thread manager, memory manager. We are going to discuss with them. We are going to communicate with them only. Got the point? Getting the point? So we are going to communicate. And the first day of operating system only I told you. First day of our Linux module only I told you. First day of our Linux module only I told you. We are going to communicate with an operating system. We are going to learn how to communicate with operating. Part of an operating system, what? Kernel. So we are going to communicate with the kernel. Is it clear? We are going to communicate with the kernel. Is it clear? So for all these things, my voice is breaking. Some internet issue is there. Just a minute. Some internet issue is there. That is maybe the reason. Suddenly power went and came. My Wi-Fi is not working. Just give me 1 minute of time. Just give me 1 minute of time. Just let it be clear or breaking or whatever. Maybe just give me 1 minute of time. I will change the network. I'm unable to connect it. Now is it? My voice is clear? Is my voice is clear now? Okay. Okay, let's see. So all of you clear about it? What is the in future? What in next few sessions? What we are going to discuss? Everywhere programming involvement will be there, except this. Is it clear? So in this, before starting with the main topics, in the last lecture we are trying to understand what is an operating system? Why an operating system in embedded system? Why Linux? What are the components of an operating system? These are the concepts in the last lecture we discussed it. So today we need to talk about booting steps of Linux operating system. Today we need to talk about booting steps of Linux operating system. And we need to talk about random number generation. If time permits, we need to talk about introduction to process management. Is it clear? If time permits, we need to talk about introduction to what is it? Process management. If this is clear, type C in the chat box. So first we need to talk about booting steps of Linux operating system. Second, we need to talk about random number generation. Third, we need to talk, if time permits, we need to talk about introduction to process management. Can anybody tell me, when you switch on the system, roughly how much time it will take to come the login screen where you need to provide a login ID password? Again, can anybody tell me, when you switch on the system, roughly how much of time it will take to come to the login screen? Maybe depends upon the systems and depends upon operating system. Maximum of 1 minute to 2 minutes. Huh? Now we are going to talk what is happening behind that. Now we are going to talk when you switch on the system. Now, as simple as possible, I'm going to talk about when you switch on the system till the login screen comes where you need to provide a login ID, password or what it may be. What are the background works are going on that we need to discuss? That is called booting steps. So actually, when you switch on the system to the login screen comes, there are 1, 2, 3, 4, 5, 6 steps takes place. Background your sense. Again, when you switch on the system till the login screen comes, behind your sense, there are 6 steps takes place. Your voice is still breaking. Just give me 1 minute. Just sometimes it is happening. I can understand. Sometimes it is happening. Please wait. Just I'll pause the screen. Now it is clear. In between disturbance is coming. I can understand. Please wait. Just give me 1 minute of time. Give me 1 minute of time. Now I connected to my this one, mobile phone. Let's see in this case. Now is it? Now my voice is clear. Previously, I connected to some other. Previously, I connected to some other device. Now I connected to my mobile phone. My Wi-Fi is not. Internet is not coming. Okay. Now, what is the discussion happening is, when you switch on the system, listen very carefully. When you switch on the system, will you agree in your laptop or in your desktop, power button will be there to switch on the system. When you switch on the system, till the login screen comes, what is the background steps are going on that we are going to discuss as simple as possible. Those are called as booting steps. How many steps are there? How many steps are there? Booting steps. How many steps are there? There are 6 steps are there. What is the first step? Just read the names of the steps. After that, we'll discuss one by one. First step is called BIOS. Second step is called MBR. Third step is called grub. Fourth step is called kernel. Fifth step is called init. Sixth step is called run level. I hope you might have remembered compilation stages. First step is a preprocessor. Second step is a translator, assembler, linker. In a similar way, when you switch on the system till the login screen comes, so background, there are 6 steps takes place. The first step is when you switch on the system, that is called BIOS. Can anybody tell me what is the full form of BIOS? Basic Input Output System. BIOS is nothing. I'll share this screen. I will share this PPT after the class. Don't worry. BIOS is nothing but Basic Input Output System. This BIOS program is present in your motherboard. You might have observed, you might have know that there is one chip called ROM chip. Do you know? In your motherboard, in your CPU, apart from the RAM and hard disk, manufacturers of the CPU, they'll put one chip in your motherboard that is called ROM chip. In this chip, this program will be there. This is also program, BIOS program. All of you are getting the point, type 1 in the chat box. All of you are getting this point, type 1 in the chat box. So when you switch on the system, when you give a power supply to your laptop or your desktop, the first program which is going to run, that is called Basic Input Output System. This program is not present in the RAM. This is present in the ROM chip. So what it will do? It will perform some system integrity checks. System integrity checks means, I don't know if you are using the CPU. If you are using the CPU, so when you switch on the system, will you agree BIOS error will get? How many of you observed this type of BIOS error? Anybody knows? Type 2 in the chat box. BIOS error you will get. BIOS error you will get. So what this BIOS program will do, the minimum hardwares which is required is those are connected properly or not, they will check. Again, yeah, in a blue screen it will come. Yes, in a blue screen, BIOS error. BIOS error you will get. So what this BIOS program will do, the basic input output peripherals are properly inserted, are properly connected, are properly working or not, it will check. Like, will you agree? To run the system, RAM is very important. To run the system, motherboard is very important. To run the system, hard disk is very important. Will you agree? Will you agree? Now tell me, to run the system, RAM, hard disk, motherboard, these are very important devices. So these devices are properly connected or not, it will check. They will check. That program will check. It will send some signal, wait for reply. If a reply came, means the device is connected properly. Now tell me, is monitor is a important device for loading an operating system? Without monitor, operating system can be loaded or not? Answer is yes, it is loaded. Monitor is not a important device. Will you agree? But RAM, operating system must and should be loaded into the RAM, right? As I know, in the next steps, operating system must and should be loaded into the RAM. Will you agree? Hard disk also should be loaded. Will you agree? Hard disk also should present. Without a hard disk, there is no. So what this BIOS program will do, it will communicate with those devices. Don't think about how they will communicate. They have their own set of rules and regulations to communicate. So they will communicate with these devices and they will wait for the reply. If everything is correct, it will go to the next step. Otherwise, it will show you the BIOS error. Normally, network administrators in our lab, what commonly they will do is, if dust particles are accumulated on the RAM slot, then also BIOS error will get. If dust is accumulated in the CPU, if more dust is there, so more thing is there, so then what happens is, so they will remove the RAM slot, they will clean it, and they will once again insert it, so that again it will come. Sir, in which language this BIOS program is returned? So mainly, when you go for the low level, it is assembly. When you go for the low level, they return in assembly. I don't know, one of the company, AMI, American Megatrends, they will work on the BIOS program. There are so many students, your seniors, they are working on this. Is it clear? Basic input-output system. So where it is present? So manufacturers of the motherboard, what they will do, they will dump this BIOS program into that ROM chip. And also observe, it will perform the system integrity checks. I mean, system integrity checks means, in a simple way, if I say all the basic input-output peripherals are properly connected or not, so they will check. And also searches, loads, and executes a bootloader. Now tell me, when I told you, when I write /a.out enter button, when my program is loaded into the RAM for execution. Similarly, somebody need to load an operating system into the RAM. Can you tell me where the operating system is there? I'll give you the two options. One is a hard disk and another one is a RAM. In a ROM, operating system will not be there. First, operating system is present in the hard disk. From the hard disk, it should be loaded somebody. First, operating system is installed in the hard disk. From the hard disk, it should be loaded somebody. And also, yes, in a C folder. And also, I don't know how many of you know, through pen drive also you can boot OS. So in this BIOS bootable pen drive, yes, in this BIOS you can change the priority also, from where the bootloader operating system should be fetched. Is it from the pen drive? Is it from the CD-ROM? Is it from the hard disk? Is it from the network? Nowadays, the operating systems through network also you can boot. Through networks also you can boot it. Means operating system present in a server. From the server, operating system is going to be loaded into your system. So that type of settings you can do it in the BIOS program. First bootable priority, second bootable priority. So those things you can do it in the BIOS settings. Is it clear? Now any disturbance is coming? I don't think so. Now any disturbance is coming? No. So now I connected, no problem, through mobile. So this is one of the program which is present in the ROM chip. Who will load this program into the ROM? Can you tell me who will load this program into the ROM? Can I say manufacturers of the motherboard? Motherboard manufacturers. Motherboard manufacturers will load this program into the ROM chip. This is the first program. When you switch on the system, this program executes. Now, during this BIOS startup, to change the booting sequence, you can change the booting sequence also. Booting sequence means from where the OS should be booted. Booted means loaded. We can simply simple word if I say loaded. From where it should be loaded if it is. Second step is MBR. So BIOS will give the control to MBR. MBR is nothing but master boot record. Master boot record. It is located in the first sector of the bootable device. I don't know how many of you know, when you're talking about hard disk, they will call the term called sectors. Hard disk, magnetic disk, it is called as a sector. So the starting portion of the hard disk, MBR, the starting portion of the bootable disk, MBR will be there, master boot record. So BIOS program will initiate MBR. MBR is the first, it is present at the beginning of the bootable disk. Suppose your hard disk is a bootable. Can I say in the beginning of the hard disk, some record. Record means very simple. If I say a record means one table. It is located in the first sector of the bootable device. MBR is less than 512 bytes in size. This is very less size file. MBR is 512 bytes, less than 512 bytes. It contains the information about the grub. What it contains? MBR contains the information about the grub. What is that grub? We will discuss it. So in simple terms, MBR loads and executes the grub. So the first BIOS having its own work. After that, the control given to MBR. MBR is not a program. MBR is one record, one file which is present in the starting sector of your bootable device. In that starting sector, grub information will be there. Is that clear? Is the second step is clear? Type 2 in the chat box. MBR is nothing but one file, one list. Like in your, it is applicable for only booting the OS. Yes, booting the OS. Especially we are talking about a Linux OS. Grub. Grub is nothing but Grand Unified Bootloader. Grub is nothing but Grand Unified Bootloader. Every operating system has its own loader. Windows operating system loader name is NT loader. Again, every operating system designers, they design their own loader. Loader means, can you tell me, loader means, will you agree, which will load something? The name itself tells you. Loader means, will you agree, it will load something. So what is a Windows operating system loader name? Can you tell me what is the Windows operating system loader name? NT loader. NT loader. Linux operating system loader name is LILO. Lilo loader. Again, Windows operating system loader name is NT loader. Linux operating system loader name is LILO. Lilo loader. But we are talking about which loader here? Grand Unified Bootloader. This one of the specialty of this loader is, using this loader, Windows can be loaded, Linux also can be loaded. Lilo, there is no full form. If I don't know, you can search it in the internet. LILO. C3, got the point? You can search it. So every operating system designers, yesterday in the last lecture I told you software, right? Operating system is a software, right? So every operating system designers, what they will do, they will design their own loaders. every operating system designers, they will create their own loaders. So Windows loader name is NT loader, Linux loader name is Lilo loader. But which loader we are talking here? What is the third step we are talking? GRUB, Grand Unified Bootloader. The specialty of this loader is it will load, depends upon your choice, it will load which operating system you want, you can select. It can be used for Windows as well as a Linux. I don't know. Those who know our lab infrastructure, in our lab, most of the systems are having Windows as well as Linux, dual booting. When you switch on the system, it will display one screen. In that screen, Windows will be there, Linux will be there. Listen, all of you are observed in the lab. When you switch on the system, multiple operating systems are there. And also some of the systems, if it is not working, you might have observed grub error, G-R-U-B, grub error. In our lab, you might have faced this type of things. Some systems, if it is not working, when you switch on the system, on the screen, you might have observed grub error. So the specialty of this grub is, it can load multiple operating systems. One thing I need to tell you, Linux. Now, will you agree? In your laptop or in your desktop, you can load multiple dual booting, Windows and Linux. You can make it dual booting, Windows and Linux. Yes or no? In a Linux also, I don't know how many of you know it or not, you can put multiple kernels. Kernel means manager. Multiple managers you can put. You can put multiple kernels. If you see, I don't know, in this it will work or not. uname-a, this command, so 4.4. So what the Microsoft people they did is, because Linux is a free source code, so they've taken that as an advantage. They created one app. All of you are observing this app. They created one app. They created one app as a Linux. I'm using Windows as a subsystem in a. I'm using Linux as a subsystem in a Windows. Will you agree? I'm using Linux as a subsystem in a Windows. So what I need to tell you is, if you are working purely on the Linux, you can put multiple kernels in your system. So what the grub will do, grub will display what the grub will do. If you have the multiple kernels, if you might have installed, it will ask you to wait. If multiple kernels, if you might have installed, multiple operating systems are there. So what the grub will do, voice is again breaking. What the grub will do, grub will so this is the thing. We are talking about a third step, grub, Grand Unified Bootloader. What the grub will do, grub will load the kernel. Kernel means, can I say core of an operating system? Kernel means core of an operating system. So all the managers are loaded now. Now the operating system is loaded. Operating system is loaded meaning is the managers are loaded into the RAM for execution. Operating system is loaded means the managers are loaded into the RAM for execution. All of you are getting this point? So who will load the kernel into the RAM? Can tell me who will load the main part? Kernel is nothing but a core of an operating system. Who will load the kernel into the RAM? Can I say grub will load the kernel? In a lab, you might have observed, because in our lab, most of the systems are having Windows as well as Linux. So the grub will display which one you want to load it into the RAM for execution. Again, If you have multiple different operating systems, so what the grub will do, grub will display which operating system you want to load. And also, I don't know you have observed or not, at that display, the down, some time will be there. It will keep on decreasing, 30, 29, 28. If you go to the lab, you can check it out. So depends upon your choice. What happens is the grub will load the kernel into the RAM for execution. Where the kernel is present, where kernel means, can I say, core of an operating system. One of the student told Windows operating system is present in the C drive, but Linux is present in S bin. Kernel executes one. After loading the kernel, what it will do, it will execute one program which is there in the S bin, that is called init, init. Now, can you tell me, in a simple word, loading the kernel, what is the meaning? In a simple word, loading the kernel, what is the meaning? In a simple word, loading the kernel, what is the meaning? OS is loaded into the RAM in this step. Now, can you tell me where the OS is present? Can you tell me where the OS is present? Where the OS is present? Can I say in a hard disk? So before loading it, it will mount the root file system, mount the file system. It's very difficult to understand what is a mount, but how many of you know ext2 file system, ext3 file system, FAT file system, FAT16, FAT32, NTFS. These are the file systems. Without a file system, there is no meaning of the data in a hard disk. Again, without a file system, there is no meaning for the data which is present in the hard disk. One of the speciality of the Linux is Linux will understand all other file systems also. Can anybody tell me, in a pen drive, which file system will be there? In a pen drive, which file system will be there? Is it NTFS? FAT file system, FAT32 will be there. Because of that file system only, we are able to communicate with a pen drive. Because of that file system only, we are able to communicate with a pen drive. Every operating system has its own file system. Linux file system is ext2, ext3, ext4 file system. Windows, NTFS. All of you are getting this point. Without a file system, there is no meaning of the data which is present in the file, in a hard disk. So, in step number 4, first file system gets mounted. After mounting the file system, kernel gets loaded. After loading the kernel, means all the managers, kernel will execute one program that is called /sbin/init program. First program which will execute when you switch on the system. One thing I need to tell you, RAM space is divided into 2 parts. I hope all of you know that RAM is divided into 2 parts. What are those? RAM space is divided into 2 parts. One is a kernel space and another one is a user space. Again, RAM is divided into 2 parts. One is a kernel space and another one is a user space. Can you tell me who is there in a kernel space? Can you tell me who is there in a kernel space? I'm not talking about different types of RAMs, B8, M2. I'm not talking about different types of RAMs. In a RAM, divided into 2 parts, one is kernel space and user space. Who is there in a kernel space? All the managers are present. Process manager, memory manager, file manager, thread manager, network manager, signal manager, memory manager. All the managers are present in the kernel space. Who is present in the user space? Our applications, our programs. Our programs will run in the user space. Our programs will run in the user space. All of you are getting this point? So once file system gets mounted, once the kernel is loaded into the RAM, so the first program starts executing in the user space, that is called init process, process. Init. This is one of the process. This is one of the process which starts, first process which starts in the, this is first process which starts in the user space. This process runs till you switch off the system. This process runs till you switch off the system. One thing I need to tell you, the programs which are running in the user space, those are technically called as the processes. The programs which are running in the kernel space, those are technically called as a services. Again, the programs which are running in the user space, those are called as a processes. The programs which are running in the kernel space, those are called as a services. Now when you go to the bank, can I say you are the customer, means you are the process. Bank employees are services, they will provide a service, right? They are also persons, we are also human being. Now, with respect to operating system, this is also one program which is executing, this is also one program which is executing. But this program is not an application. These programs are services which will provide a service to applications. These are the programs which will provide a service to applications. So in the next few sessions, we are going to, our aim, our goal is to communicate with the services, right? We are going to create a processes which is going to communicate with the services. All of you are getting the point? All of you are getting the point? So what is the first program when you switch on the system till you switch off the system? What is the first process in the user space? It will start executing till you switch off the system. The process name is INIT, init process. The name of the process is init. Observe. Since init was the first program to be executed by the Linux kernel, it has a process ID of 1. What is a process ID? What is the parent process ID? Everything in the next few sessions we need to discuss. BE9S7 is asking one question. Sir, means in laptop we have the C disk that is related to OS and already filled with some memory that are services. Services, yes. I don't know, you might have observed or not. When you install the Windows OS, some services will be there, some applications are also there. Default it will come. Will you agree? When you install the Windows OS, this application will come automatically. Applications, whenever we want, we need to start. Services, when the operating system is loaded, they started executing. BE9S7, getting the point. Applications means whenever we required. Now can I say, can I close this application if I want? Can I close this application? Yes. But can I say this application internally communicating with a file manager? This application internally communicates with a file manager. Will you agree? This application internally communicates with the network manager, because through this application only my voice, my screen, everything you are able to. This application communicates with the network manager. Now, just now you observed, if my network is not proper, there is no use of this application. If some disturbance is there in my network, means in my service, so there is no use of this application. If you're getting the point. So these are applications. These are not started executing when you switch on the system, when the operating system is loaded. When operating system is loaded, when the kernel is loaded, only managers are started executing. Managers are ready to serve you in a kernel space. And one program starts executing in the user space, that is init program. This is the first program. And also when you switch off the system, this is the last program. From switch on the system to switch off the system, this program will execute. All other processes are under the control of this only, init only. For all other processes, init will run in the user space. In a simple way, if I say init runs in the user space. So what the init will do, init, all the small services, it will start running. It will start init will execute some of the small programs. I don't know how many of you observed, in a Linux operating system at the time of booting, if it is not a GUI, there are so many messages will come on the screen. If it is not a GUI, there are so many messages it will come. Means all the small services started running. That is called run level programs. So what the init will do, what this init will do, it will start all the small programs. So have you heard about one thing called, have you heard about something for sending the mail, for receiving the mail, there is one service called SMTP, Simple Mail Transfer Protocol. In the networking, you will learn it. SMTP is one of the service. Like this, all the small programs, started running at which level? All the small programs started running at run level programs. TFTP, FTP is correct. File transfer protocol. Yes, file transfer protocol. All these are started running. These are called as the small services, not the major services. Small things. Who will execute this? Who will start these services? Who will start this? Can I say init will start? Init will start. And also in this step only, one important point is decided, at which run level your OS should run. There are 6 levels are there, no need to worry about it. One is single user mode, multi-user mode, and network enabled. Like this, different things will be there. Without network. Now one thing I need to ask you, those who are coming to the lab, when you switch on the system, can I say it is connected to the network server default? Will you agree? When you switch on the system, will you agree it is connected to the, directly connected to the server? But your normal laptops, normal desktops, can I say it is not connected? Multi-user mode, full multi-user mode, multiple users. So in which mode it should run, it is decided. After everything is done, if everything is done smoothly, then the login screen comes. If everything is done smoothly, then the login screen comes. If I summarize this, if I tell you in a step by step, so when you switch on the system, the first program starts executing. When you switch on the system, the first program, that is a BIOS, where it is present in the ROM chip. What is the job of this? Just it will check basic input output peripherals are connected properly or not. If not connected, BIOS error it will get. And BIOS will give the control to MBR. In the BIOS settings only, where the operating system, what is the first priority of an operating system, it will decide it. So BIOS will give the control to MBR. MBR is one record which is present in the starting sector of your bootable device. Can you tell me some of the bootable devices? Can you tell me some of the bootable devices? Can I say your hard disk? In your hard disk, OS may be there. Pen drive, network also boot. From network also you can boot. What you call CD-ROM also. So MBR is the first sector of the bootable device. It contains the information about the loader. I'm talking about one loader, that is the specialty of this grub loader is it can load any operating system. Grand Unified Bootloader. I told you every operating system designers, they will give their own loader at the time of designing an operating system. So grub specialty is it will load multiple, depends upon your choice, it will load it. What the grub will do, grub will load the kernel. Now here Linux comes to picture. In this grub you might have collected the windows. Can I say Windows managers are loaded? In this grub you might have selected the Windows. Can I say Windows OS is loaded? But we are talking about a Linux, so the grub will load the kernel. Loading the kernel is nothing but all the managers are started executing in the kernel space. Will you agree? Loading the kernel is nothing but all the managers are started executing in a kernel space. So after all the managers are started executing in the kernel space, the first program starts executing in the user space, that is init program. That init, what it will do, it will enable small services. It will enable small services. So then next is init will enable the run level programs. Run level program means it will enable the small services. Once everything is done fine, everything is fine, then what happens is, once everything is fine, then what happens is, can I say login screen comes? Can I say login screen comes? So once the login screen comes, you need to provide a login ID password. Once we supply a login ID password, what happens is, you can utilize the services by taking the help of applications. You can use the services by taking the help of applications. Is that point is clear? D3, yes. Whatever you are saying. Don't worry about in detail about all these things. In details, maybe in a, what you call real-time operating system we are going to discuss. Sir is going to discuss. Don't worry about in detail thing. Where the files are there, everything Pramod sir will discuss. Is that point is clear? In a simple way you need to further time, because to understand our main target is process and process management. To understand this, very basic information is required. I don't know, you able to recollect it or not, able to point it or not. When we started with the preprocessor, when we started with C language, we discussed the preprocessor, but as simple as we discussed. At the end of the C language, also we discussed the preprocessor, little bit detailed. Here also the same thing. Here also the same thing. So just single line explanation for this. In future, in a RTOS, you are going to get more points about all these things. Now, in which step number our OS is loaded? In which step our OS is loaded? Can I say fourth step? Third step OS is loaded. Means third is a grub. In a third step, OS is loaded. That is a fourth step. Is it clear? Where the bootloader information is there? Where the bootloader information is there? MBR. Where MBR is present? Where the bootloader is there means in MBR. Where MBR is present? MBR is present in the starting sector of your bootable device, maybe pen drive, maybe hard disk, wherever it is. in a starting memory section. What is the size of MBR? What is the size of MBR? It is a 512 bytes. Just it is a table which contains where the grub is located. That location information address will be there. Is that point is clear? Everything is done fine. So what happens? Command what you call it? Everything is done fine. What happens? So login screen will come. You need to provide a login ID password. You need to utilize the applications to communicate with the services. User uses the applications. Applications need a services. Services are capable of communicating with the. It is a bytes. I think 512 not bits. It is a 512 bytes. It is a 512 bytes. Is it clear? M1. So this is about the booting steps of a Linux operating system. So next discussion will be random number generation. Random number generation. This topic is individual topic. So this topic you no need to correlate with any other things. Now can you tell me OTP generation? You might have observed you will get an OTP in your mobile number. Can I say that is one random number? Can I say that is one number which is randomly? Maybe 3-digit number, 4-digit number, you will get it. So now we are going to discuss what is the procedure to generate. What is so many games also they will use this type of things. What is the process? What is the procedure to generate a random number? So the functions involved in the random number generation is rand and srand. It's taking some time. The functions involved in the random number generation, note it down, rand function and srand function. All of you noted down this prototype of these functions, rand and srand. Noted down. Rand is useful for generating the random number. I'll write it better. Rand is useful for generating the random number in between 0 to rand max. One thing I need to tell you, from now onwards, you need to start making a habit of reading the man pages. Again, one thing I need to tell you, from today onwards, you need to start making a habit of reading the man pages. Rand function is used to generate random number in between 0 to RANDMAX. I'll show you this. Just a minute. Observe here. RAND_MAX. Again, rand function is used to generate a random number in between 0 to rand max. Can I say this is one macro? Will you agree this is one macro? Rand max is one macro. RAND_MAX. Can you tell me where this macro is present? In which header file can you guess this macro will be present? In which header file this macro will be present? Can I say std lib.h? I'll open that std lib.h. Vi, just observe, vi slash usr slash include std lib.h. I'm opening that header file, try to observe it. All of you are observing line number 86. Can I say rand function will generate a random number in between 0 to this much big number 2147483436. Rand function is useful for generating the random number in between 0 to that much. Are you getting the point? 2147 means up to 4 giga. Will you agree? I'll show you, it will be more clear. I'll show you, it will be more clear. I'll try to generate 5 random numbers. 2308 underscore 1.c. So I'll include stdio.h. I'll include, what is that header file? std lib.h void main. Now can you tell me, when I declare a local array, what is the storage type of this array? When I declare a local array, what is the storage type of this array? Can I say auto storage type? What is the default values inside this? What is the default values inside this? Can I say garbage values? Okay. Now observe. For I is equals to 0, I is less than 5, I plus plus. A of I is equals to rand. For I is equals to 0, I is less than 5, I plus plus. Printf %d space A of I. So in this program, I'm trying to generate 5 random numbers and I'm trying to print it. Rand function is returning one number, some random number. I'm storing into A of 0, A of 1, A of 2, A of 3, A of 4, like this. I'm storing into that. All of you are getting this point? Rand function is generating some random number. That number I'm going to store it into this array. Let me compile the code. That random number must and should be in between 0 to 2g. Will you agree? That random number must and should be in between 0 to 2g. 0 to rand max. See, is it a 0 to rand max? Whatever the numbers it is generating, is it a 0 to rand max? Is it in between 0 to rand max? Yes or no? Please let me know. Now, can anybody tell me, if I do modulus with 100, what is the possibility of getting the remainder? Any number modulus with 100. Any number modulus with 100. Can I say 0 to 99? Any number modulus with 100 when I do it. So minimum I may get a 0, maximum I may get a 0, maximum I may get a 99. Can I say here I'm trying to generate a random number in between 0 to 99. Here I'm trying to generate a random number in between 0 to 99. But one thing I need to tell you, every time the same sequence of random numbers it is generating. Every time the rand is generating the same sequence of random numbers. How many times when you execute, those many times it is giving the same sequence of random numbers. Those are random numbers. Will you agree? Those are the random numbers. Will you agree? But every time when you execute a program, it is executing the same, it is giving the same sequence of random numbers. Now to change the sequence, you need to use one function called srand. I'll write it here. Rand underscore max, right? srand function is used to provide seed to rand so that rand will generate another sequence of random numbers. Okay, with the help of srand, what we can do, we can change the sequence. Otherwise, every time the rand will generate the same sequence of random numbers. Again, otherwise rand will generate same sequence of random numbers. Somewhere in the man page you will observe. Here. If no seed is provided, if no seed value is provided, the rand function is automatically seeded with the value 1. That is the reason every time it is generating the same sequence of random number. Now how to change the sequence? I need to use, how to change the sequence? I need to use srand. Now can you tell me what is the seed for the rand now? By default seed is 1. Now 2. Now let's see. Seed is nothing but some input. Will you agree? Previous random number generation, random sequence, and now this sequence is different. Seed is nothing but some input you are providing, so that internally with that input it will generate some different random numbers. BE8, E2, got the point? Seed is nothing but some different input you are supplying, so that that rand will generate another sequence of random numbers. Okay. Now, previously the seed is what? 1. Now the seed is what? 2. Now can I say once again when I execute, same sequence it will generate? Once again when I execute, same sequence it will generate. Why? Because same seed. I will agree, every time you need to change the seed. Instead of that, what you can do, you can use one function called getPID. Don't worry about what is the getPID. Maybe in a tomorrow session and day after tomorrow session, we are going to talk. Every time you need to change the seed so that you will get a different sequence of random numbers. Again, every time you need to change the seed so that you will get a different sequence of random numbers. Otherwise, every time when you execute, you will get the same sequence of random numbers. So to change the sequence, getPID is nothing but a process ID. Correct. Every time the process ID will change when you execute. Observe. So function we need to declare it. Don't worry. We need to include a header file. Now observe different sequence of random numbers. Will you agree? Every time the seed is changing that. So that is the reason rand is generating a different random numbers. Getting the point? Now, but all of you are observing the rand is generating random numbers in between 0 to 99 only because modulus with 100 added. Now, can you tell me if you want to generate the random number? If I want to generate a random number, 3-digit random number, maximum of 3 digits. 3 digits means up to 999. Will you agree? Modulus with 1000. Yes. If you do modulus with 1000, you'll get 3 digits. Suppose I want to generate a random numbers in between 50 to 100. Suppose I want to generate a random numbers in between 50 to 100. Now, can anybody tell me in between 50 to 100, how many are there? Can I say 51? 50 to 100, can I say it is a 51? So now tell me, rand modulus with 50, rand modulus with 50, what it will generate? 0 to 49. If I write modulus with 51, if a rand modulus with 51, can I say 0 to 50? Rand modulus with 51, can I say 0 to 50? Plus 50. If it might have generated 0, 0 plus 50, 50. If you might have generated 50, 50 plus 50, 100. So we are able to achieve 50 to 100. Again, try to understand. Suppose my requirement is I need to generate a random number in between 50 to 100. Suppose I want to generate a random number in between 50 to 100. If I want to generate a random number in between 50 to 100, how many numbers are there in between 50 to 100? Can I say, including that, including 50, including 100? Can I say 51? 51. Yes, sir. So, just a minute, T2. So, if I use rand function, modulus with 50 or modulus with 51, can I say I'll get a possibility lowest number I may get as is 0, highest number I may get, lowest number I may get 0, highest number I may get 50 in this expression result. Will you agree? So that I need to do plus 50. So 0 plus 50, it is a 50. 50 plus 50, can I say 100? So in this way, I can generate a random number in between 50 to 100. So that I can generate a random number in between 50 to 100. So 51 plus 50. One of the student is asking, explain sixth line. If you don't use this sixth line, every time for rand, the seed is 1 only. Every time it will generate same sequence of random number. Every time it will generate a same sequence of random number. To generate a different sequence, we need to use srand function. Getting the point? To generate a different sequence, we need to use srand function. In this srand, you need to provide one number. But every time same number means same sequence it will generate. Every time same number means it will generate a same sequence. That is the reason for generating a different sequence, I am using a get PID. So what is this get PID? In the next session, we'll discuss it. Now let's see, are we able to generate our desired range or not? Are we able to generate desired range or not? K9, B9, K2, that is an extra efforts, right? Whatever checking the condition is an extra effort. Checking the condition is an extra effort. So instead of that, directly you can use this. ./a.out. See, whatever the number it is generating in between 50 to 100 only. So today I'll give you two tasks. Task 1 is try to generate a random numbers, 3-digit random numbers. 3-digit random numbers means 100 to 999. Will you agree? Your task is to generate a 3-digit numbers. 3-digit random numbers means 100 to 999. Second task is you need to generate 5 random numbers in between 0.25 to 0.75. Again, two tasks to you, today's tasks. One is you need to generate 5 random numbers in between 100 to 999, 3-digit random number. And second task is you need to generate random numbers in between 0.25 to 0.75. Second task is you need to generate random numbers in between 0.25 to 0.75. If these two tasks are clear. Anyway, after the class, I will share this program in the LMS. This PDF I will share in the LMS. So is this task is clear? Type C in the chat box so that I will wind up the today's session. If the task is clear, so that we will wind up. Two tasks. We need to generate 5 random numbers in between 100 to 999, 3-digit. Another one is we need to generate a random number in between 0.25 to 0.75. Okay. This is about the random number generation, how to generate. So this is an individual topic. This topic we need to use in the future in the process management. The notepad, rand is used to generate a random number in between 0 to rand max. And srand is used to provide a seed between the rand and seed so that rand will generate another sequence of random numbers. I'll show the program. Anyway, I'll share the program in the LMS also immediately after the class. Now here the rand is generating in between some random numbers. Modulus 51 means it will generate minimum 0, maximum 50. If it might have generated a 0, 0 plus 50, 50. If it might have generated 50, 50 plus 50, 100. So this program is for generating the random numbers in between 50 to 100. This program is used to generate a random numbers in between 50 to 100. Is it clear? This can be used for OTP generation. Suppose you need to send one OTP. If that OTP is correct, only you need to further process it. That type of situations you can use this. It's clear. I'm going to wind up the today's session. Tomorrow, theoretical concept, process and process management. Tomorrow session, entirely the theoretical concepts. Tomorrow, process and process management.